Assalamualaikum and selamat pagi. My name is Zadi Ikram Bidana Abidin and my metric number is CF220114. I'm from group 6. For my project of static dynamic, I have choose to check on the balcony at Perwira. So without further ado, let us check whether the balcony is safe or not to use for the resident in Perwira. A structural component known as a cantilever beam spans horizontally and is supported at only one end. The cantilever end, which extends past the support point, is the unsupported end, such as balconies, roof, and other overhangs are frequently supported by cantilever beam. In construction, in order to extend the deck out over a body of structure, they can also be employed in bridges and other buildings. In this research, balcony at Perwira building block H are chosen to be calculated with actual size 750 mm length with, and that's all. To be concluded, cantilever beam at block H Perwira with assuming the uniform distributed load UDL is 15 kN per meter with the length distance for the balcony is 0.75 meter and the type of reaction is identified as fixed and support. The first calculation shows that the value for the axial force is equal to 0 kN because there is no direction of the force in perpendicular to the area resisting it, while as for the shear force is equal to 11.25 kN after the uniform distributed load are react over the distance of the beam. With the value of shear force moment for the cantilever beam against half distance are collected using the moment formula, which is M equal to Fd. Henceforth, the centroid of the structure are identified with x-axis are equal to 0.858 meter and y-axis equal to 1.5 meter. Meanwhile, for the second moment of inertia, the stresses in beam and column for this structure has been determined with the IXX stresses equal to 0.454 meter the power of 4 and IYY equal to 0.385 meter the power of 4. With the data collected through calculation, the balcony is safe to use for all residents who live in Perwira. That's all from me. Thank you very much.
Hai, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Khairul Nazam bin Jamaluddin. My metric number is CF220003. Okay, for this project of static dynamic, I choose column and fracture at the fellow house at the TDI as a main fracture. The structure that I have choose is a frame. Those they are made up of a beam, column and a slab. This is my structure at the TDI. The structure of the frame is called column and beam and supported by the two columns. The length of column is 5 meter and the width is 1 meter. The type of reaction identified is support, pin and roller for the both column. The length of the beam is 10 meter and the width is 1.5 meter. To be concluded, the column at the TDI assume distribute load UDL is 15 kN per meter. Calculation. For the first calculation, show that this structure, for example, force at point A is 0 kN. Because there are no direction for the force perpendicular to the area existing in. Shear force at point A, which is total Fy is 0, and total moment is 0 because there are no fixed end. Total for RB equal to 15 kilonewton, and also for RA is equal to 15 kilonewton. Because the both of column have the same distributed load to transfer the weight and force on structure to the foundation and to the ground. For the centroid, I decide to divide it in 3 segments, which is segment 1 is for column, segment 2 for beam, and segment 3 also for column. The centroid for the structure are identified, which x axis equal to 3.2 meter and y axis is equal to 1.45 meter. Meanwhile, for moment of inertia for this structure have been determined with their ISS is equal to 1517.16 meter power of 4, and for IYY is equal to 27.95 meter power of 4 for the y axis.
Hello everyone, my name is Gilbert Gipsam. My metric number is CF220038. I am from group 6. For my static and dynamic project, I choose bridge at block E15 at UTHM for my structure. So let us see whether that bridge is secure and suitable for people to cross over. So this is my journey to block E15 where my structure is located. It takes about 15 minutes to walk on foot from bus stop to go to the bridge. The assumed data for the load of this bridge is 500 kg and for the slab is 2000 kg. The length of the bridge is 4 meter in length. As for the height of the bridge, it is measured 1 meter. The bridge at block E15 have assuming the uniform distributed load act on beam that is 73.56 kilonewton. For the first calculation, this structure have 0 kilonewton for axial force because there are no direction of the force in perpendicular to the area. Shear force for this structure is 0 kilonewton. As for moment, there are 73.56 kilonewton. I decided to divide the bridge into 4 segments. The centroid for the bridge are identified with x-axis that is equal to 1.87 meter and y-axis equal to 0.43 meter. The moment of inertia for this bridge structure have been determined with their IXX that is equal to 1.1967 meter power of 4 for the x-axis, and for IYY is equal to 28.60 meter power of 4 for the y-axis. From the data collected and calculated, the bridge at block E15 is safe and secure for the people to use. That is all from me. Thank you.
Hello, my name is Junino Star Nalidan, metric number CF220099. For my structure, I choose a beam at my own dome at College Kediaman Perwira. Let us see whether that beam is strong and suitable for the structure. The estimate load for my structure was 25 kN with a length of 7 meter with a height of 1.5 meter. I believe that this beam carries no more weight such as beam under this building because this beam is at the highest level of this building, which is at level 4. It only carries the load from roof and roof trusses. For point load, I have calculated the point load at 175 kN. The force reaction for AY and BY is equal, which is 87.5 kN. There is only one shape in this structure, so there is only one centroid of this structure that needs to be calculated with a total of 12.25 meter cube for AX and 0.875 meter cube for AY. The moment of inertia for this beam structure at x-axis is 0.073 meter, while for y-axis is 14.291 meter. For conclusion, we can assume that this structure is strong and stable based on the estimate calculation that was done. The structure's construction material is appropriate for residential design. Considering its size, this design is also very common and simple to construct. The values of the support reaction, centroid and moment of inertia have all determined, and they are all logical and reasonable by estimation. Last but not least, while constructing a structure, whether large or small, we must be wise and cautious in selecting the material, size, strength, and durability, because all of these are crucial to ensuring the structure is robust and safe for human usage for a long time.
Assalamualaikum and a very good evening. My name is Muhammad Kwan Haziq bin Jauhari. My matrix number is CF220100. For my structure, I chose trusses at Uncle Lorry building in front of Perwira. I will calculate to prove if it's suitable for the main structure. My estimating load for the structure that I choose, mass of load is 0.5 Newton times 5 because of 5 point is it. The length is 9 meter. I believe this trusses is not carry more than this load because it only carry rain load and wind load only. For the support reaction of roof trusses, analysis of reaction, I get 1.25 kilonewton, and for the RA is 1.25 kilonewton because I think it's equivalent. Calculation for the centroid, my structure I picked was triangle, but I think I got 2 section only because of triangle split it into 2. You got both sides equal the same length. And then for the magnitude X, I got 3.75, and for Y magnitude I got 1 meter. For the moment inertia of my structure, I got 2 sections. They the following for the sum up all the IXX equal to 0.000193 times 10 power of 6 meter 4. And then for the IYY sum up, I got the 0.000122 times 10 power of 6 meters 4. Therefore, the conclusion is this structure has proven strong based on the estimate has been done, appropriate to stay. The value support reaction, centroid, and moment inertia, they are all logic and reasonable. Lastly, we must ensure the structure must be safe as an engineer. Thank you.